Our topic for today is I can use rules to add and subtract integers. So we're going to build off of what we've seen when we've added and subtracted integers using the number line, and we're going to use that to come up with some rules, some patterns that we can use so that we can add and subtract without the number line. If you haven't already watched it, or if you need a refresher, go to YouTube and find the War in Mathland video. It's a great 3-minute video that gives some context for positive and negative values and what happens when we add them together. As you watch the video, ask yourself, what rules could we use to remember how to add and subtract integers without a number line? And we'll be using principles from this video throughout this presentation. So, when we are adding the same sign, the rule to remember is that the sign stays the same. So if I start out having a positive number and I add more positives to it, kind of like in the war video, if I have a positive army and I add more positives to my positive army, I end up with lots of positives. Similarly, if I have some negative and I add more negative, I'm going to just have lots of negative, okay? But my answer will have a negative sign. Another way to think about this is if I owe my sister some money and then I owe my brother some money, well, together, I still just owe a lot of money. I still have a negative balance. Okay. Now, if we're adding numbers with two different signs, so we start with a positive and we're adding negatives to it, or if we start with a negative and we're adding positives to it, we want to know what the sign of our answer will be. And the answer is, it depends. So remember in the war video, if the positive army is bigger than the negative army, then the positives will win. And the opposite is true. If the negative army is bigger, then the negatives will win. So this is what I want you to do. When you're looking at an addition problem where the signs are different, look at the numbers without the sign and ask yourself which one is bigger, the positive value or the negative value. And that will tell you the sign of your answer. So some examples. Okay, in our first example here, 4 plus negative 3. I'm going to look at the 4 and the 3. 4 is bigger. So, since 4 is positive, I know that my answer is going to have a positive sign. Okay, there's more positives than there are negatives. Now, how many more? Well, there is one more positive. So the answer to this problem is positive 1. Looking at the second problem, I have 3 positives and I'm adding to that 7 negatives. Well, 3 or 7? 7 is bigger, and it's actually 4 bigger. So my final answer here is negative 4. Now don't forget to include that sign. A lot of people can tell that the difference between the two numbers is the 4, but you need to remember the negatives had the bigger number, so it has to be a negative answer. And we could demonstrate this on the number line. So if you'd like to, go ahead and try this on your own. Compute the same two problems using the number line rules, and verify that we got the same answer. Okay, when we are comparing these two problems, what we notice about the difference is, even though they both have the numbers 3 and 2, in the first example we're subtracting a negative, and in the second example we're adding a positive. Okay, so we've kind of got opposite things going on. What do we notice about the number line evidence and solutions? Well, even though because there are the two negatives, so we had to flip our arrows twice, other than that, everything else is the same. That we moved forward in the positive direction 2 spaces, and we ended up at 5. So what we can notice about this is their solutions are the same. So what can we learn from this? Well, we can learn that subtracting a negative is equivalent to adding a positive. So I'm just going to do subtracting a negative is equal to adding a positive. Now, this time, we have the similar pattern. We have subtracting a negative compared to adding a positive, but we started with a negative number. And we just want to verify that that wasn't just some random problem that happened to work, that it works with negative numbers and not just positive numbers starting. If we look at the number line diagram, we see the same pattern that we saw last time. So what we can learn is it doesn't matter what the starting number was. If we're subtracting a negative, that's the same as adding a positive. Now, this example is a little different than the previous two. In this case, we are subtracting a positive number. How do I know it's positive? Because there isn't a negative sign. Okay, so I'm subtracting a positive. And a lot of people might say, well, how do you know that it's subtraction and not a negative sign? Well, we have to have some sort of operation between the two numbers. Although, as we'll see, subtracts and negatives are often similar. Okay, the next one, we are adding a negative. Okay, so here we're subtracting, here we're adding. In the first one, we have a positive. In the second one, we have a negative. So they're basically opposites in both ways. So that's what's different about the problems. But look at their number line evidence and solutions. They're identical. So not only do we have the same answer, but the solution is the same. So what we can learn from this is that subtracting a positive is the same as adding a negative. And so we can switch back and forth between the two. The reason why these examples are helpful is because if we use the addition rules that we learned at the beginning of the video, and if we can take subtraction problems and change them into addition problems, we can use these same addition rules with any problem. So here's some examples. We're gonna use the a phrase keep, change, change. So I keep the first sign, I change the operation, I change the second sign. So let's take a look at these. 3 subtract negative 2. I keep 3 positive, I change this negative to a positive, I change this negative to a positive, and it becomes positive 3 plus 2. Okay, let's take a look at the next one. I'm going to keep this a negative 6. I'm going to change this to positive, and this becomes negative 6 plus 4. Last example, I'm going to keep this a negative. I'm going to change this to a positive and this to a negative. And you want to be careful because there is that hidden positivity. So you want to make sure that you remember to change that to a positive, subtract to a positive, and the sign to a negative. So we end up with negative 1 plus negative 3. And then we can use our addition rules. Positive plus positive gives us another positive, positive 5. Negative plus positive, they're opposite signs. I have more of the negatives, so I have negative 2 as my answer. And negative plus negative, the sign stays the same, so I'm going to end up with negative 4. And if those 3 examples didn't make sense to you, go back and review those addition rules. Take a moment to practice the following problems without a number line. If it is an addition problem, use the addition rules. If it's a subtraction problem, change it to addition first using keep, change, change, and then use the addition rules. Pause this video while you practice and then start it up again to check your answers. Problems 4 and 5 were subtraction problems, so on them my first step was to change them to addition using keep, change, change. So these are the new addition problems that are going to have an equivalent result. And here are our answers. So I have 2 negatives in number 4, so I'm going to have a negative answer. The answer is negative 8. Number 5, I had a negative and a positive. I had more negatives, so I have a negative answer, negative 3. Number 6, I had a positive and a negative, more positives, so I have positive 6 as my answer. Number 7, I had a negative plus a positive, more negatives than positives, so my answer is negative 5. if you need to, go back and re-listen to any part of the video to make sure that it makes sense to you. Thanks for watching.